Here we go. Today's lesson, we're going to go through exercise 1D and E. So ideally I want to spend more time on 1E. 1D I'm going to quickly whip through the concept. So try to understand the concept, okay? Write the notes or watch the video again. But the idea is the concept. It's a very easy concept. It's a tedious exercise to do, okay? And you do happen to play around with it more often in the application type questions. Or exam 2. There we go. Exercise 1D, sums and products of functions. Sums and products of functions. Whoops. What is that? Oh no. How do I do it? There we go. Say you have two different functions. Okay, you have, let's say, f of x and g of x, right? Typical example would be, let's say, the one that you've seen in year 9, x squared plus x. Technically, that is a sums of two different functions. You have a quadratic, which is x squared, and you also have a linear. Technically, it's a sum. But you didn't learn it like that when you sort of learnt in year 9. What you learnt was that's a quadratic, and you factorized it to be x plus 1. You found the x-axis intercepts, and you just sketched your graph as 0, -1, as a positive graph, and you would have drawn it like that. Yeah? What I'm going to teach you today is how to add these two using the one concept, and you'll see that why it actually looks like this too. Okay? Same concepts as well. Right? And then this thing will make sense, why it actually looks the way it is, and why that also works. Okay? But when we say sums and products, so once you understand sums, you technically understand difference. You understand difference, you also understand product and quotient. Okay? Because it's all the same thing. It's only under one concept that you can split up a function and you can separate into add, subtract, multiply, or divide those functions. Okay? Now, let's have a look at, let's say you can sum, add, and products is times, and so that's how we write it. We say f of x plus g of x, we write f plus g, all of x, or you can say f of x times g of x, which is the same thing as saying f times g, all of f, or all of x. Okay? Now, the example I gave here is x cubed and x squared. You can find out the two here. This is your x squared graph in blue, and your green is in x cubed. When you find the addition or subtraction or multiplication, all of it is the same. The concept I want you to take out of 1D is to understand, well, what are you multiplying? What are you adding? What are you subtracting? Okay? What you're adding and subtracting, and what I want you to understand here is right this. When you say f of x, technically this is your output, or your image, or your y coordinates, or your range. So this is your image. This is your pre-image. So when we say add and subtract f of x plus g of x, what you're really saying there is you're adding y coordinates. When you say here f of x times g of x, what you're really saying is multiply the y coordinates of both functions. Because that's what it really is. When you sketch x cubed, which is the green one, that's your x cubed. The only reason why you can see it is because they're made of infinite coordinates, or ordered pairs. They're made of infinite coordinates, and those coordinates have an x coordinate and a y coordinate, and the y coordinate is the image. That's why you can see it. And so they're infinite images, and what you're really doing when they say add or subtract or times or divide is they're saying take these coordinates and corresponding to the same x coordinate. So this y coordinate, let's say for x squared, let's say x was -1, hypothetically, right? So x is -1. For this function g of x, where g of x is x squared, then g of -1 give you 1. So that coordinate there would be -1, 1. The coordinate for this one, for the cubic, at f of -1, that would be -1. So when you say f of x plus g of x, which means you're trying to sketch the graph of x cubed plus x squared, what you're really saying here is find the y coordinate for the x cubed plus the y coordinate for the x squared. So what you're really doing is you're just saying at this coordinate here, 1 plus a -1, what do you expect it to equal to? 0. So that means in the new graph, if I actually asked you to sketch h of x, which is x cubed plus x squared, I already know one of the coordinates has to be at -1, 0. Okay? And that's a very simple concept. That means you can do that the same for products, times, subtract, divide. It's the same thing. all you're really doing, I want you to take out that in terms of concept, what you're really trying to understand is you're just adding, subtracting, multiplying y coordinates. That's why you can analyze these graphs here. You can say, oh, that means at this point, where they both intersect at 0, 0, x cubed plus x squared, what would the new coordinate be for the new graph? What would it be at? Right at 0, 0. If we were to add the y coordinates, what would it give me? Have a guess. Might be right. No, I'll tell you then. All right. If you have 0, 0, both graphs, this is the x cubed graph, and this is the x squared graph, which is f of x, g of x. Naturally, your new graph, x cubed plus x squared, where would the coordinates be? 0 plus 0 will give you 0. And then, if you think about it logically, where the intersection is, I don't care what value that is. All I just need to understand is if I'm adding them together, this y coordinate, if that was a height of 7, if I'm adding those two together right at the intersection, what would my new coordinate be? Where would that lead me to? Think about it. Where would that lead me? You both have the same y coordinate, so your new coordinate has to be at yes? 14. Because remember, you're just adding y coordinates. Right now, whatever that intersection is, intersection between x squared and x cubed, what number is that? What's x cubed and x squared? Cube of what number? 1. So there must be 1. Sorry. So there must be 1 there. So 1 cubed and 1 squared will give you 1 there. So that means x equals 1. That's 1. If this is 1, 1, they both have 1, 1. And that means, if you think about it, if I said h of x equals x cubed plus x squared, h of 1 will give me 1 cubed plus 1 squared is 2, which makes sense because you're just doubling that height. So this is your new x. So why am I talking about this new x? Because I've just labeled a couple of points here. I just labeled the graph has to go through here, has to touch 0, and has to touch 0 here. So if I'm actually analyzing each of every one of these coordinates, you're just taking out as this goes larger, this is x squared, this is a negative x cubed. Now let's just try to think hypothetically, if I went into the negative direction of x-axis all the way to infinity, which one's larger? X squared in the negative direction or x cubed in the negative direction? Which one would have a larger number? Cube. So that means it would be much more negative than it is positive. Now if you add negative and positive and it's much more negative, what's your overall answer? Is it more negative or is it more positive? More negative. Good. Because you've got such a large negative. It's like saying negative 1 million plus 10. Is it overall positive or is it overall negative? Overall negative. So you know your next graph at some point is going to have to go down, which is why that's 0 there. Because as this goes, this gets more negative and negative. So most likely the graph is going to go down. Okay, and it passes through this point here. So that's where the equilibrium is, right there. That's where the equilibrium is. In between it is still positive, but apparently I'm going to go back to 0 as well. And then most likely it's going to come back up. See what I'm doing? I'm just estimating. We would never really know what the entirety, what it exactly looks like, but we can estimate it. So this whole subject, or this topic, the reason why I say it's tedious is because you're analyzing it. It takes a long time to do it, but it's a very simple concept to do because all you're doing is you're picking out some questions and you're plotting them and you're finding the main points to sketch. Now, these main points that I want to teach you, the things to look at when you're doing sums and products or differences or quotients of functions, you're looking for 1, intersections. Okay, so I'm going to write it down. You're going to have 1, intersections. Any other intersections is easy because if you've found the intersections, adding just means double that. Subtracting means 0. Because you got 1, take away 1, give you 0. So intersections are nice. Origins are nice at number 2. Why are origins nice? Because they both have, or one of it has a y coordinate of 0. 0 plus something, 0 times something. It's easier to figure out where your coordinates would be. After that, any asymptotes. And then lastly, now's your job. And what we did just then was we had to figure out larger number and smaller number. And we have to say if we added them, what the overall sign would be. Is it more positive, negative? You might look out into the positive integer, positive infinity. Which one's getting larger, which one's getting smaller? If you subtract them, does it make a difference? If you add them, what happens? Okay, and that's your goal. So that's the hardest part, and that's the most tedious part because you've got to analyze between here and here to the intersection. If I add these two, logically it makes sense that it'd just be a bit larger. Because if I took this number plus a little number, of course it'll be slightly a bit bigger. If I took this number plus this y coordinate, obviously it'll be slightly larger. But I know, right at this point here, whatever this length is, it plus itself has to give you double the length. So I know that there has to be a coordinate right up there. So already I know if I were to add these functions, it has to look like that. They both touch at 0. If I add these two, this is now negative plus a positive. But we know that for cubics, between 0 and 1, the cubics is much smaller than it is for squares. Okay, so that's why it's in the positive region. But then as soon as you pass negative 1, cubics will be much larger in terms of the direction or the magnitude. So that's why it will have a little slit that comes up and comes back down. Okay, and so what I'm saying is I'm taking this number plus a bit of a, plus another number makes it slightly larger. That's why it looks like that. But it never touches the green line because you're always adding a bit of a blue. So naturally, you have some graph that looks like that. And that's what you're going to do for every graph. So I can give you, let's say, y equals, I don't know, x squared plus square root of x. I might not know exactly what that looks like, but I can tell you already that it won't have any negative values, and it only stays on the right-hand side. In fact, if I had to guess it, this is an x squared graph, and I'll draw the square root graph. Let's say that's the square root. They both intersect at 1. So 1, 1. What would the new graph look like? So if I draw it in green, what would the new graph look like? Well, they both start at 0. So, okay, I have a 0 line, 0 dot. 1, if I had to add these two, so it's x squared plus square root. So these two y values add together. This is 1 plus another 1 makes it 2. So I know it has to be up here. If I want to now estimate the insides, this is the square root function plus an x squared. Obviously, if this is the square root y values, add on an extra x squared has to be slightly bigger than your square root. So that means every number here has to be larger and larger and larger. It goes like that. Now from here, x squared plus a square root function, what we know, or what we can see, is if we're estimating, look at this black line, it gets much larger than it would for your red line. So if you took a very large number plus an extra small number, it's large plus a small. So your overall answer would have to give you a bit of leeway, but it follows this parabola. So my answer must look something along the, whoops, just a bit larger what you see there. But it doesn't have any negatives. Why? Because the square root doesn't have a negative. So what are you going to add? There's nothing to add. Doesn't make sense. This is why the first property of your sums and products, the first property says the domain of your first function has to be in common with the second function. Why? Because how can you add two numbers if the other one doesn't exist? See, this one is like, all right, at -1, I have a coordinate, but at -1, the square root function doesn't have a coordinate. So how do you add something that has 1 plus undefined? What's the answer? Undefined. That's why the first property in your slide says domain of f needs to be intersection of domain of g. What it's really saying is you can only add coordinates if they have the same domain, if they're within the same region. Okay? So, let's do a couple of examples. I was just trying to show you the logic of what I was trying to show you before. This is your sums of products of an x squared, x cubed, and I estimated it, and yes, that is correct. It goes up, it comes back down. That's where -1 must be. Okay, let's do a couple other ones so you can see. This is x cubed with g of x is -x. Okay, and same thing. This should have came out as an animation, but didn't. No, it didn't. All right, it was meant to come out, if you look at it, this is your x cubed in green. This is your negative x in blue. Your new graph is the red. Let's analyze it. Same thing. If we analyze it, this is your center. Obviously, if you add the y coordinates, it's right there. It doesn't change. Find intersections. That was the only intersection. Other than that, that's it. So from here, now you're just going to look at each of these values and you add them. Which one's larger, which one's smaller. So think about a green and a blue. Green and a blue. Green and a blue. If you think about it, green is a cubic. Cubic graph has to get really large. It's x cubed. Whereas this is negative x. So if this was negative 4, this would be this is positive 64. Now positive 64 minus 4. Obviously it's just slightly smaller. Smaller than what? Smaller than your x cubed graph. Okay, so I'm going to repeat that again just so you understand. If this was 4, and x equals 4, you have 64. So 4, 64 gives you that coordinate. At 4, this is negative 4. Okay? If I said take the y coordinate of x cubed, so x cubed plus a negative x. Okay, if you have a look at that. Okay? Addition of ordinates, if you just think about sums of this negative x graph, the y coordinate's negative 4, so this is negative 4. Right, and then you got sum with x cubed, which is 64. 64 minus 4, 60. This is your new coordinate for the sum of these two graphs. Notice 60 is smaller than what? 60 is smaller than 64, because it makes sense. You had 64 and you minused 4, because all these numbers are minusing. They're getting smaller and smaller and smaller and smaller. But let's have a look on this side then. If we're looking on this side, this is your cubic graph. You're taking this number plus a negative number plus your y values for the straight line. So of course it goes up, because it's a very small x plus a larger y. Okay, so it goes up, but then why does it go back down? Why does the red one go back down? Because remember, this must be negative 1, because negative 1 cubed gives you negative 1. Okay, this one will give you positive 1. So it makes sense that positive 1 minus a 1 gives you 0. But after that negative 1, think about it, just if I chose negative 2, negative 2 cubed would give you negative 8. But then negative 2, now if you add those two numbers, negative 2, negative 8, what are you going to get? You get a much more negative. That's why it goes down. You see, so all I'm doing is the hardest part of what you guys got to do in 1D is to estimate, is to predict, as this gets larger, which one's larger. If you add, subtract, multiply, what happens to the graph? That's the hardest part that you have to do. But the concept was easy. What was the concept? Within the domain, you add, subtract, multiply, divide. Simple as that. So what you had to take out of 1D was this. All you had to understand was they have to have the same domain, common region for you to add. Number 2, you're just adding or multiplying the ordinates, okay? Sum and products, that's all you're really doing. What are the ordinates? Your y coordinates. Simple as that, so I'm going to write it down again. Addition of ordinates, what are you really adding? Adding y coordinates. That's what you're really doing. That's all you're doing, okay? So f of x and the domain, this means same region in order to add. Just logically, you can't add if they're not in the same region. One takes a negative, the other one doesn't, so one's undefined. How can you add something that's undefined? Doesn't make sense. So logically, that's why you have the property, function f has to be the same as domain of function g. Add those two together, what are you adding? Y coordinates. What are the tips for you to learn in order to plot? Origin, intersection, any asymptotes, and then finally the last one is interpret what happens when it gets larger, which one's larger. That's the hardest part. Okay, so try to get the basic ones down, find the origin, find an intersection, and you plot those points. That's how it works. So it's an easy concept, tedious exercise. So if you get it, if you do a few and you get it, move on. 1E is more important. Okay, if you understand what I'm saying, that's all you need to do. Okay, you just need to understand you can add, subtract within the same domain. What you're adding, subtracting, multiplying, or dividing is y values. That's all you're doing. Any questions? Cool. All right. I think I had a couple examples, so I'll just kind of quickly go through them so you can see. Turning points, points of intersection, axis intercepts. Hey, I got that x squared and square root. Hey, how about that? This is a good one for you to see. So what I'm trying to show you, these are the points I want you to look at. Any asymptotes, intersections, origin, which I didn't write, but axis intercepts is origins as well. Okay? Larger, smaller, so this is the hardest one. Interpreting for larger or smaller numbers. Okay, so let's have a look. This is your square root function that I've drawn incorrectly. Very incorrectly. I must have done it a different way then. Oh, no, I've done it correct. Do you know why? Because that's f of x minus g of x. So technically, you're really saying, I thought I did it wrong. I didn't. Why isn't it working? Oh, my pen's dead. Oh no. Why do this to me? Oh, I guess I'll do the whiteboard. Hold on a second, where's my bag? Alright, what I'm trying to say is because it says f minus g of x, what you're really doing is you're doing f of x minus g of x, which really is x squared minus root of x. Remember to sketch a negative root of x, that's what it looks like. That's negative root of x. Positive root of x would have been the other way. Okay, so now I've got the two graphs. What's your job? Find intersections, axis intercepts, predict what would happen. Okay, have a go. Just draw this quickly in your graph. You don't have to be accurate. Okay, just predict. Roughly, what would happen if I go positive infinity, negative infinity? What should the new graph roughly look like? Just have an estimate. Okay, roughly estimate. Just using these points here. No asymptote. Let's guess. Remember, you're adding y coordinates. You're adding y coordinates. Alright, gotta quickly go through this one. There's two ways of doing this in case you thought that you had a different idea. You could think of it as if you drew the f of x as you normally would, okay, I mean g of x as you normally, the square root function, root of x, you can actually just say take this one, subtract that one. That works too. What I'm doing over here is I'm saying take this one, add that one. Because what I'm saying is I'm saying x squared plus negative root of x, because I sketched a negative root of x. If you sketched a positive, then you change that. Okay, same thing. So it depends on how you want to visualize it. Okay, so if you prefer to look at it like this, and you can see the intersection is 1, 1, that helps you, draw it that way. Okay, it's up to you. Because this one at least tells you that 1 minus 1 is going to give you 0. So you know that there has to be an intercept there. And there's an intercept here. Okay, and then you just have to predict, does it go down and up, or does it go up and down? Okay. You don't have to clarify. When you write the function, if they say sketch the graph and write the function equation, then yes, you have to write it in the restriction. But when you're sketching it, they can tell from your sketch that there's a restriction. And you're right, there is a restriction. Alright, let's see, did you get this graph? Roughly. So I'll do it again. This is your... So you can see I was predicting that it would cross through at 0, which is there at 1, because x squared is 1, and root of 1 is 1. If you add those two together, negative 1 plus 1 is 0, so it makes sense. The question was, does it go down and up, or does it go up and down? And the easiest way to figure that out is think about, well, which number is larger? See, an x squared versus a square root. You think about it, if you had like 10 squared, that already gives you 100. Whereas if you had root of 10, that's not going to give you 100. You see, 10 squared is much larger. You're going to have 100 plus a negative root 10. Obviously, it's going to be slightly less than your original, which is shown here. You see, it's slightly less. Instead of it being here, it's here. Instead of it being up here, it's here, because you're always minusing whatever the values are for the square root. Okay? So it was logical that in between 0 and 1, between 0 and 1, the quadratic is a very small number. It's like, if it was half squared versus root of half, this one's always going to be larger than this one, because this already makes it a quarter. Quarter's 0.25, gets smaller. So the larger the denominator, the smaller the number is. That's why between 0 and 1 you have to be very careful. And that's what they want to do in the exams. They will always try to get you between the 0 and 1, because the fractions change, especially when you compare between x cubed and x squared. You see, if I put half in, you're thinking half should give you a larger number, which is 1/8. But 1/8 is actually smaller than 1/4. Because the larger the denominator, the smaller the number is. So between 0 and 1, either positive or negative, you've got to be careful when you're looking at that. And that will determine whether you go down, whether you go up. Cool? Alright, so that's what exercise 1D is. That's the concept. Please take that, have a look at the video again. We're going to now move to 1E. Make a new page. This is really where a lot of concept is coming in. Okay, there's a lot of effort into 1E. Why are you gonna... Oh.